This lesson shall deal with a specific kind of time, distance, and speed problem that deals with boats that are traveling on streams or rivers. The main concept here is that the boat has a speed of its own, but the river that is flowing underneath the boat has a speed of its own too. Rivers are not stationary. The water also flows with a certain speed. This speed affects the speed at which the boat travels on it. These kind of time, distance, and speed problems exploit this particular fact. Before we go further into understanding this concept, there are a few important relationships between the direction of motion of the stream or river and the direction of motion of the boat that we must understand. First, let us assume that there is a river which is flowing in this direction. There is a boat on the river which is moving in the same direction as which the river is flowing. Such a scenario is called downstream motion. That is, if a boat is traveling down a river in the direction in which the river is flowing, the boat is said to be traveling downstream. Likewise, if there is a river which is flowing in one direction and a boat is attempting to travel in a direction opposite to the river's flow, that is called upstream. That is, if a boat is trying to move against the flow of a river, the boat is said to be traveling upstream. Sometimes water isn't flowing, as in water would probably be flowing in a river or in a stream. But if you take a lake, the water is stationary, it doesn't flow. In such a case, if a boat is moving on water, it is said to be still water. That is, the boat has a still water speed. The water isn't moving, so it's not affecting any of the motion of the boat. Now assume that the boat can travel at a speed of x. The river on its own is flowing at a speed of y. The effective speed of a boat when it is moving downstream shall be x plus y. Likewise, if there is a river flowing at speed y and there is a boat attempting to travel upstream at its natural speed of x, the effective speed with which the boat shall actually move upstream of the river shall be x minus y. The basic concept is that if there is water flowing underneath the boat, either it can support the boat's motion and take the boat along with it, or it can oppose it. That is, it is difficult for a boat to move opposite to the direction in which a river is moving. There are two key formulae in boats and streams that we must remember. First is a formula related to the speed of the boat. Second is a formula related to the speed of a stream. We know that the downstream speed of the boat is still water speed plus speed of the stream. Still water speed is a speed at which the boat can travel in still water, so it is the truest judge of the boat's capabilities. That is, how powerful is the engine, how fast can the boat go. That is determined by its still water speed. We know that the downstream speed is still water speed plus speed of the stream, and upstream speed is still water speed minus speed of the stream. Therefore, we can derive that still water speed is equal to downstream speed plus upstream speed divided by 2. The speed of the stream, therefore, again is downstream speed minus upstream speed divided by 2. So these are the key formulae in this kind of question that you must keep in mind. Let us now look at some of the different types of questions that can be asked. The first kind of question will ask you to find what is the boat's speed. For example, here is a question. A boat travels upstream at 15 km per hour and the speed of the river is 2.5 km per hour. What is the boat's downstream speed? We know that upstream speed equal to still water speed minus speed of the stream. Therefore, 15 equal to still water speed minus 2.5, or still water speed equal to 17.5. Downstream speed is equal to still water speed plus speed of the stream. So downstream speed is 17.5 plus 2.5 equal to 20 kilometers per hour. In the second kind of question, you will be asked to calculate the speed of the stream. For instance, let's take this question. A boat with still water speed of 15 kilometers per hour travels 30 kilometers downstream and back in 4.5 hours. What is the speed of the stream? Now, one thing which you must keep in mind is that the basic principles, the basic fundamentals of boats and streams. Now, one thing which you must keep in mind is that the basic principles and ideas in a boats and streams problem are those of time and distance. So, all the same shortcuts of time and distance, same formulae of time and distance, and same general idea of time and distance problems can be put into boats and stream problems. The only thing you have to keep in mind is that if a question involves a boat traveling on a river, you have to include the downstream or upstream speed as required. If you recall from the lecture on time, distance and speed, when two equal distances are traveled with different speeds, the average speed is 2 s1 s2 divided by s1 plus s2. In this case, the boat has traveled 30 kilometers downstream and returned. The total distance traveled is 60 kilometers. The total time taken is 4.5 hours. So average speed equal to 30 plus 30 divided by 4.5. Substituting it in the formula and then reducing it to simpler terms gives us the still water speed of the river at 5 kilometers per hour. We have thus shared with you the basic idea of how to differently tackle a time, distance and speed problem if it involves a boat and a stream. The key things for you to remember are: the boat shall have a different speed if it is traveling downstream. The boat shall have a different speed if it is traveling upstream. The speed of the stream can either aid in the motion of the boat or it can hamper the motion of the boat.